What is up, everybody? It's Ken Q here. We're going to do some programming today. So today we are going to continue on the Steganography program, i.e. hiding text in images. If you recall last time, we got to the point in the program where we could completely encode a message into an image. We did the entire encoding side, and then I showed the two images kind of side by side. And you could see, if you looked really closely, some minor differences in the white pixels. And so today we're going to continue on and do the decode side of things. So if you recall, our input text was this message. And hopefully, when we finish programming the decode, we'll run it on the image we created last time and see if we can get the same image back out. Additionally, I want to see what happens in the alpha part of this. Right now, we're not dealing with the alpha channel, but we are dealing with the values of things where it's completely transparent. So I want to see what happens when we write to those areas and then decode it. So to begin with, you might see in the command line here, I was doing a little playing around because this section of code here is just ugly. And I realized why it was ugly. My int to binary function here doesn't specify that it has to be eight values in length, essentially. So it produces a binary string, but it doesn't have to be 8 characters. So if I specify 8 characters, then it will give me a full 8-character string, and it'll be padded with zeros. And we can test that. So even if we take, for instance, a equals 20, and we go format a, and we say 0b, right? We get 5 characters, but if we go with that, we get the padding. Enough zeros to pad it to 8 characters. And that's what we want, and that'll get rid of that whole if statement there. So if we make that 8, then we don't have to worry about the length of a being 0, because it'll always be 8. We don't have to worry about being 1, because it'll always be 8. So we can get rid of that whole section, and then do the double pop. So here we assume that the string of characters, when it's not 0, we encode it into the thing. So essentially, we know it's going to be an even number of binary bits, because everything's 8, and that's a multiple of 2, and however many multiples of 8 you have, it'll still be a multiple of 2. So it'll always be an even number, and since we're dealing with an even number of bits in the image, then we don't need to worry about having an odd bit on the end, or a slightly smaller. Like if we were dealing with the last 4 bits, it's possible we could have the last character be only 2 bits of the pixel rather than 4, and we would have to deal with that. But here, because we're only dealing with 2 and it has to be even, it's either going to be 2 or it's going to be 0. So that's great. So let's save that. That's going to work. That's simplified. All of this work in just 62 lines of code so far. So now we start the decode. Decode. Okay. And from the decode, what do we need to do? What are the basic functions? So we have an image file path. So we need to, let's see. We need to get the bits from the image. The last 2 bits. What do we call that? So start decode. We'll call that decode image. So image or encoded message bits, decode image. And all we need to pass there is the IFP. Okay. So decode image. File. Image array. Read. File. Easy. And we don't need a bit list. So for an in image array for n in m and for value in range. We need all of this to be identical. So a equals list int to binary of n value. Okay, so that is our string of 8 bits for the color channel of that 1 pixel. So what we need are the last 2 bits of that. Processing. All right, I got to run a quick test here because I'm not sure how this works. So if I have a list, a equals 1, 2, 3, 4, 5, and I go a dot pop minus 1, what happens? I get 5. Minus 2, 4. And then if I did minus 1, I'd get 5. And then A would be left with that. Beautiful. So I want to do minus 2, then minus 1. So, bit string is equal to empty. It's to binary. So we get a string out of that. It's a list. If I did a string equals hello and I list string, yeah, it's still strings within it. So we have a bit string. Bit string is equal to bit string plus a dot pop minus 2. And then minus 1. And when all is said and done, we will return bit string. Cool. Now we have our bit string. Start decode. Okay, encoded message bits. So do we have a... We have a text to binary, but do we have a binary to text? So let's say we have binary to integer. So let's say okay, let's just leave it at 8 for now. Okay. B equals int a comma 2. B is 52, and then str b won't work. Text to binary. CHR 4. That doesn't seem right. Okay. Quick lookup. Python int to ASCII. I think I need an encoding. Yeah. Oh, apparently it's just the CHR. Yeah. So what if I did like CHR 200? That's not fair. 90? Okay. So it's a thing. But I have to do it a character at a time. So let us go here somewhere. Def binary to character. Bit string. Return. Return CHR. No, int to character. No, binary to character. Character. Okay, wait. Processing. So if it's binary, we got to first turn it into an integer. So binary to integer. Bit string. There. Binary to character. So ASCII string is equal to decode binary string encoded message bit. Yeah. Okay. Bit. Decode binary string. Def decode binary. Yep. Bit string. Okay. For I 0, comma, len. It's string over 8. So it'll be 0 first. Bit string bracket bracket I times 8, so 0, and then at 1 it'll be 8, which is good. 2 I times 8 plus 7. Jeepers. So first will be 0 to 7, and then when I is 1, it'll be 8 to 15, and so on and so forth. So character bits is equal to that. ASCII string is equal to ASCII string plus binary to character char bits. Return ASCII string. Sweet. So now we've got the string of characters, but it's got a bunch of garbage on the end. So what we're going to do is we're going to unpackage it. So message comma hash is equal to unpackage ASCII string. Okay, we got a def and unpackage somewhere. A string. A equals hello dot goodbye. A dot split at the dot. And I got a list. There we go. That's what I want. Okay, so when unpackaging this, if I recall correctly, we added some things. M, MH, and H. So anything after H bracket is garbage. So good stuff, comma space, garbage is equal to a string dot split. And we're going to split it at the end of the hash. Anything after the end of the hash is garbage. Good. Actually, we won't call it good stuff. We'll call it okay stuff. This is where my variable naming will go to complete and utter garbage. Better stuff. Nope. More garbage. Comma space. Better stuff is equal to okay stuff dot split. And we're just going to split off the tag at the very front. Good stuff. No. Message, comma space, hash is equal to better stuff dot split. And we will split it on the middle delimiter. So we should be left with a message and a hash. And we'll just return message and hash. Easy. So now we've got a message and a hash. We want to hash the string again. So vhash is equal to hash string message. Okay. If vhash is equal to hash, then status equals 1. Else status equals 0. Right? But we're not done there. We still need to output the message. So okay. Def write contents message with open, and the path will be secret message.txt, comma, for writing as f dot write message. So here we will do write contents message. If the hashes don't match, we're not going to write it. For now, we'll just write it no matter what. That should be it. How many million errors have I made here? What's the file name? So Python steg decode, and the path is medium_steg.png. Bitstring, invalid syntax. What? What is invalid there? I probably forgot a colon somewhere. Missed a bracket. Easy. Next. Def binary to character. Boom, forgot a colon. Next. The decoding is longer. The decoding is longer because it has to go through the whole image, whereas for the encoding, it skips a lot. For I in range. Okay, where is that? Yeah. Print len bit string over 8. Ah, I see. Float object cannot be interpreted as integer. Well. If you make it, and we know it's always going to be 8 because it's all 8-bit stuff. Expected to got 1. Expected to got 1. Does that mean our encoded thing isn't there? Expected to got 1. That's the right thing, right? Okay, first and foremost, what I might do, just gonna get rid of all of this for now, and we're gonna write the ASCII string to the text file. Oh, yeah, this is supposed to be in finger quotes. Status is not defined, of course. But I think the file was written nonetheless. Whoa. Yeah, it definitely didn't do it correctly there. Okay, hold up. I am discovering something that I did not expect. Python, because I go here, I go straight text binary with this string join format thing. Right? But apparently, if I have a string, let's say, or a character, or if I go ord, I get the value for it. And then if I go, I get the character back. Contrast that with this. And if I take that string and convert it to an int, I get 104. Okay. So that's fine. What does that mean? What if a, sorry, a equals hello. Okay, I have a string there. Okay, we have a binary string. Binary string converts to a list. We pop off the end to of the pixels. Pop off the end to bits of that color. Yeah, you can pop them off in any order, it doesn't matter. And then you just take the next two from the top. B dot pop. Right. C equals list of B. Yeah, C dot pop. Okay. Yeah, no, that should work. Oh, I could do that here as well. For I in byte array bit string. Anyway. So let me just put this here. The secret message definitely didn't come out right. I wonder why. Input text. Okay, let's output the. Let's do a few things. When we're encoding, let's print bstring. Okay, and then we make a list out of it. String.join a. Why? Oh yeah, that turns the list into a string. Oops. Let's get a few test points in here. Print n value. Actually, you know what? Go old equals n value. Do. Print encoding string. Yeah. So that's all the encoding stuff. print encoded message bits. Okay. So let's close that. We'll delete secret message.txt. We will delete the steganographied picture. We'll exit this. We'll go Python, steg encode, and then what? It's image file, then text file. So medium.png and input text.txt. Shoot. I did that wrong. Okay, wait. All of this can be in the if statement. Because A does not survive from loop to loop. There. Because we only need the first few. Yeah, so the value's changed. For sure. I don't know what these zeros and ones are. Oh, it's a transparent area. So M, this is a test phrase, blah, hash, blah, okay. And then there's the binary. So I'm just gonna encoding. And I'm just gonna copy these lines. There. Decoding. So now we have the steg image. At the beginning, there's some variety. Don't know where it ends. Ah, right here. And it looks exactly identical. Okay. So I'm doing something wrong somewhere because it's going to be in the decode. Is it? Okay, wait. Decode image works fine. Then we print the encode bits. It's in the decode binary string part. This one. So we have a blank ASCII string. And we print the length over 8. That's fine. It's super long. It's going to be in this slice here. So let's see, range 0, comma, space 20, whatever. Whoops, gotta be in Python. Range 0, comma, space 20. A equals range 0, comma, space 20. A. Huh? For I in range 0, comma, space 20. Print I. 0, 1, 2, 3, 4, whatever. Okay. So let's say we have a bit string. A equals hello, my name is bippity boppity boop. Bippity boppity boop. And then we go A equals, or B equals A bracket 1 times 8, which in this case is 0. And then 0 plus 7. 3, 4. Ah, it's got to be 8. There we go. That's why. So now if we look at that, secret message. Yeah. Okay. Let's just open this over here so you can see it's in there. And it's got everything. It's got the tags and all that good stuff. So now that we're happy with that, we got to go and rip out all our print statements because we know at this point we're good. Up to here, things are going okay. Let's see. Don't need this. Don't need that. Don't need that. We don't need that. And then the rest of this will probably work just fine. Delete secret message.txt. Save this. Oh yeah. Status equals 1. Secret message.txt. Reload it. Bam. Look at that. That's amazing. So our input text and our secret message output match. It's a beautiful thing. So now, I don't think I'm going to play with the alpha today. I might save that as like a side exercise. But let's take an image. Let's see. I'm going to take my character image, actually. Where is it? Delete, delete, delete. pictures. Which one's a good one? Let's take this one. Copy. Paste. So the picture I'm using, let me just get it up on the screen. Is going to be this little dude here. Okay. And then, what secret text shall we write for it? Welcome, everyone, to the planet Mars. Today, we will be probing your minds for secret information. I hope you all have had a complete breakfast, since it may be the last meal you have for a little while. Please be seated and review the documents in front of you before we begin. Save that. Message.txt. Yeah. Okay. I will now run this encode. We're going to do gb4.png, and the message will be message.text. Status 1. So we should have chibi4_steg.png. We do. Look at that. Yeah, I'll show that on the screen. Doop. There. Looks totally different, doesn't it? Just kidding. It looks exactly identical. You wouldn't even know there's a secret message. And we can decode that now. Decoding, decoding. Status 1. That's what I like to see. And our secret message says the exact same thing. All right. So now, what I want to do is I'm actually going to open up a drawing tool. Just quickly. Create a new file. We'll make it 50 by 50. It's not going to be big. Set the background opacity to 100%. Just use the picker to make sure it's 255. Export to the desktop into the programming folder. Okay, so let me just get rid of some of the clutter in this folder. Keep message, delete secret message, delete input text. Okay, and now we will encode the message into medium.png. That's fine, low contrast image. So we have, let me just grab these one more time. Whoops. Browse this file. And then the steg file. They're pretty small, all things considered. Kind of like that. And if you look closely at it, I personally can't tell the difference just looking at the square. If I open with, let's say paint, and we select the white, can we look at it? Edit colors. Yeah, red is 255, green is 252, and blue is 252. So now what I'm going to do is I'm going to post it to Twitter, and then I'm going to download it, and then we're going to decode it. We'll see if Twitter does anything to it. Okay? Just give me a second. Nothing to see here. Totally just a blank white picture. Don't even worry about it. Hashtag. Hashtag Steganography. Tweet. Then we will save image as. Oh, interesting. Okay, open image first, then save image as WebP file. Oh yeah, Twitter's doing something to it. Hold up. There's got to be a way to... where'd it go? Share. The heck is a WebP file? It should just be a PNG. Test.png. Hopefully that worked. It seemed to download okay, as long as I saved it as a PNG. So now we will decode it. It is called test.png from Twitter. Oh, ho, 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 ho. Could not find a back end What do you mean? It's a PNG. Why? So clearly, clearly Twitter is doing something to it. What if I copy the image, go into MS Paint? Can I do that? I'll lose the alpha channel if I do that. Don't save. I gotta go into an actual image tool. But then I gotta know the resolution and everything. It's a bit of a pain. The image data you're trying to paste has no color profile information. How do you want to interpret this data? As web? Okay, let's see. Oh yeah, it definitely compressed it. The colors aren't right. What if I do a new one and paste again, but do as monitor? Yeah, no. Twitter, my friend, you are not my friend. So if I export this as test1.png, and then I, oops, try to decode it, it should fail. Here, test one. Yeah. It fails because it doesn't actually conform to the format. That's interesting. Image properties. Yeah, so Twitter actually changes your images, compresses them in some way. They are no longer the original images that you put up there. Meaning, you can't use Twitter in this way. That actually makes me a little bit upset. Yeah, like another thing that I uploaded as a PNG if I try to download that, rather than getting that WebP format, I actually get a JPEG format. So it's been converted. So that actually puts a bit of damper on some of my plans, but it's actually not the end of the world. You can still use this to pass images via other means. Obviously, email is an obvious choice on flash drives and things like that. Because like I can decode and get the right thing. It's just passing it through Twitter. Passing it through Twitter changes it. And so you can't pass it through Twitter. I imagine things like Facebook will be along the same lines. They'll do whatever they can to store it as small as possible. And so it'll change. It will change. Makes me a little bit sad, but oh well. Thems are the breaks. So to make this really nice on decoding, you could do stuff like checking first to see if it's unpackable. Right? So in the unpack function, you could have it return, where is it? Message hash or status message and hash. Yeah. And then if it fails to detect any of these, then status will be 0 and message and hash will be empty. And then you'll just quit out with a status of 0. But I don't, like for a bare bones program, I don't think it's necessary for me to implement that right now. The functionality is all there. You're welcome to try it out, see if you can kind of spot the difference between one where the messages are encoded and not encoded, and see if you can tell the difference in the pixels. But yeah, so I'll put it up on Git, and then I'll update the description of this stream to include the link to that. And you guys can play with it, modify it, do whatever you want. I don't care. It's going to be whatever MIT license, so whatever the MIT license states you can do with it. Coolio? All right, well, that was fun. So next week, I'm excited. So in the slot where I usually do programming and things like that, I'm going to start doing, playing around with a microcontroller that I have. I was kind of messing about with it today, installing the software and just trying things out, see how everything worked. But I haven't actually plugged the microcontroller in and tried it. But next week I'll have a setup where you can actually see the breadboard that I'm working on, see the microcontroller. And when I say microcontroller, it's literally, you can go through my Twitter, it's literally just the chip of the microcontroller. I don't have any development board or anything for it yet. So it's going to be like a hardcore learning process from the beginning. And I've never done this level of messing with a microcontroller. Like I've always done like Arduino or something like that. So it's always been kind of pre-set up for me and an entire development environment. But as part of learning and growing, I want to learn to program microcontrollers, and I want to do it in using just the assembly instructions rather than C or C++ or something like that. just go down to the very, very basic low-level control. Make it as deterministic as possible. And so we'll play around with that. We'll probably do like the basic get a blinking light coming off of one of the pins. See what that's like. And yeah, so that'll be that. I'm looking forward to it. I've never done it, so it's entirely possible that we will have no success, but it's also possible that things will go well. So I'm looking forward to that, and yeah, I'll catch you next time. Tomorrow will be Risk of Rain. I'm excited to just unwind with some video games. So I hope you'll join me then. Until then, I hope you all have a good time, and keep being yourselves. Bye.